Okay, here's the latching solenoid valve circuit, and here's where it senses the current. Here's the instrumentation amplifier, and here's the gain resistance. Here's the positive terminal going to the positive voltage rail. Here's the negative one going to the negative voltage rail. So the negative is supposed to be -3 and the positive is supposed to be +15. So above 12 and below ground, to make sure that we get the right readings, because the valve is supposed to be energized at 12 volts. So from ground to 12 volts. So here we're going to turn on the negative voltage rail. Here we're going to turn on the positive voltage rail. And okay, plug in the Arduino. Okay, Arduino is plugged in, and then we're gonna plug the analog input A1 of the Arduino to the output of the instrumentation amplifier. Here you can see we're raising it by roughly 3 volts because the current's gonna go one side and then the other side. So this is to prevent the input voltage to be lower than 0 volts or higher than 5 volts. So that way we don't damage the Arduino. And yeah. So let's see. Here's the sketch. So we're gonna run this program for 10 times, and it's gonna open the valve for 3 seconds, wait 2 seconds, and then open it again, and it's gonna do that 5 times. Let's do this 10 times and upload the code to the Arduino. So compiling right now, and should upload it pretty soon. It's uploading the code right now, and looks like it's done. Alright, then here's the source that we're going to use to energize the solenoid valve. So this is the 12 volt power supply, and these are the positive and negative voltage rails where it goes to. So these are different voltage rails than the ones used for the instrumentation amplifier. And we're going to turn it on. Here is the on button to start everything. So let's see what happens. Turns on, turns off. Here it's turning on for about 20 milliseconds, then opening the valve, close the valve, opens, closes, here's the water. It's gonna stay. And right now we're not getting any current readings. We're gonna do that next. And yeah, that's what it's supposed to do. This is 20 milliseconds pulse width, so the positive current, or the current going in the positive direction, goes during 20 milliseconds, and then it goes in the opposite direction during 20 milliseconds as well to turn off the valve. Let's get the readings from the analog input. So here I'm using real term to get the values of the current through the serial port. Let's restart this. It's port 8, so yeah, this is the one. Okay, I'm just gonna turn off the power source just in case, to make sure we don't actuate the solenoid or anything by mistake, and then we're gonna upload the code to the Arduino again. That way we don't have to unplug and plug the USB cord back in and touch any circuitry or anything like that. Yeah, unfortunately there's no restart option in the code. This will be implemented in another version of this code, but for now we have to keep uploading the program again to restart it. And here is the port. We're gonna capture this. We are gonna call it something else. There's already some. Yeah, let's rewrite this file. Latching voltage capture 1.csv and start override. So yeah, let's see what happens. So we're gonna start the circuit again, and of course I forgot to turn on the power source. Supposed to open, supposed to close. Now yeah, let's turn it on now. Okay, now it's actuating the solenoid. Opens, closes, opens, closes. See the water running through. It's doing what it's supposed to do. Open, close. It fell off the platform. And turn off the power supply. It's always a good measure. Then and of course I chose the wrong baud rate. We're gonna have to try this again. Okay, let's do this. Load the code. See if it's uploading. It's uploading now. And now the correct baud rate is this baud rate, not the other one. Let's choose the correct port, stop capture, and let's overwrite that file. Okay, this time I won't forget to turn on the power supply, and let's do this again. The LEDs turn on depending on the direction of the current. The upper one is forward current, the lower one is backward current. So close the solenoid with backward, turn it on with forward, close for 20 milliseconds, open 20 milliseconds, close 20 milliseconds of current. And in the meantime, we're reading these values. I think it's we only need to wait one more time. There we go, it's done. Let's close the port and see what we got for the values. So this is always the initial reading of the voltage counts of the analog input. So we're taking the average of 5 different measurements. This is to eliminate the noise a little bit. Otherwise, the measurement from the forward current and the backward current won't be consistent. Here you can see that it flows forward for about 20 milliseconds and then here stops, so there's zero current, and here's these voltage counts map to amperes. So depending on the gain resistance, these map to a certain number of certain current values. So yeah, here I'm monitoring the current for 200 milliseconds, and then at 3 seconds we do this backwards, 20 milliseconds, and then we measure back, and then the same thing for 5 times. This is number 2, restart in number 3, and yeah, this is how it's done.